Today, for section 1.4, we're going to solve three system variables. So here's our warm-up. We're going to solve systems of equations. Our first example is 2x plus 2y equals 3, and our second equation is x equals 4y minus 1. If we see this right away, we notice that we can solve this using substitution. We're going to substitute the value for x in the second equation into the first equation. So we now have 2 times 4y minus 1 plus 2y equals 3. Use the distributive property. Combine our like terms. Add our 2 to each side. Divide by 10. And we should get y equals 5 over 10, or in simplified version, 1/2. Once we know y is 1/2, we're going to plug it in to find out what x is. Half of 4 is 2 minus 1, so x equals 1. So our solution is 1, 1/2. We solved the first one using substitution. The second one is 2x minus 3y equals 3, and negative 4x plus 6y equals 6. This one lends itself to elimination. If we multiply the first equation by 2, we would get 4x minus 6y equals 6. Our second equation is negative 4x plus 6y equals 6. When we add the equations together, we get 0 equals 12. 0 cannot equal 12, so therefore we know the system of equation has no solution. That means that the lines would be parallel. For our next example, we would have 2x minus 3y equals 3, and negative 4x plus 6y equals negative 6. Similar to the last one, but be careful of your signs. Same thing, we're going to multiply our top equation by 2 to get our coefficients to be the same. And now when we add these equations together, we get 0 equals 0. So this one, there's infinite solutions. And by infinite solutions, we mean anything that's on that line, on either one of these, which is the same line, will be a solution point to the systems of equation. That was a warm-up to practice both substitution and elimination, because that's what we're going to do now instead with 3 variable systems. With 3 variable systems, instead of talking about lines, we're talking about planes. So the first one, we're going to be solving using substitution. And when we do this, our first equation is going to be x minus y equals 5. Our second equation is negative x plus 4y plus 2z equals 3. And our third equation is negative x plus 3y minus 5z equals negative 6. When I solve the systems with 3 variables, I like to number each of the equations so I know what I'm talking about. So the first thing I'm going to do is solve for x in equation 1. So I'm going to add y to each side. And now I would have x equals y plus 5. I'm now going to substitute this value into both equation 2 and equation 3. So I'll now have negative y plus 5 plus 4y plus 2z equals 3. So I have negative y minus 5 plus 4y plus 2z equals 3. If we combine like terms, we'll have 3y plus 2z equals 8. Now this is a new equation, so I'm going to label this equation equation 4. Now my next step is going to be substitute equation 1 into 3. If I substitute equation 1 into both 2 and 3, we'll get left with only two variables, and then we can use our system's rules. So I plugged it in for x plus 3y minus 5z equals negative 6. Distribute the negative, negative y minus 5 plus 3y minus 5z equals negative 6. We combine like terms. That will give us 2y minus 5z equals negative 1. That is now going to be equation number 5. So once I have equation 4 and 5, now I'm going to use elimination with 4 and 5. We could use substitution again, but we're going to have fractions, and I know how some of you feel about fractions, so we're going to use elimination here. I look at my coefficients and I say, well, I'm going to get rid of my y's in this case. So if I multiply the first equation here by 2, that would give me 6y plus 4z equals 16. If I multiply the second equation by negative 3, negative 6y plus 15z equals 3. I add the equations together, the y's cancel out, so I'll have 19z equals 19, so z will equal 1. Now I'm just going to back substitute that. So I'm going to substitute z into either 4 or 5. I'm going to substitute it into 4. So we have 3y plus 2 times 1 equals 8. Now I'll leave right here, substitute z into 4. 3y plus 2 equals 8. 3y equals 6. Y equals 2. So now when I have if I have y and z, I can plug it into 2, 3, or 1 to find x. I'm just going to plug y into 1 here. So we're going to substitute y into 1. And we're going to say x equals 2 plus 5, so x equals 7. So now, because we have 3 variables, this is called an ordered triplet. My answer would be 7, 2, 1. We always write them in alphabetical order. Our x, our y, and our z. So even though it says substitution, we're going to use a combination of both substitution and elimination. For the next one, we're going to solve using elimination. 4x plus 2y plus 3z equals 12. 2x minus 3y plus 5z equals negative 7. 6x minus y plus 4z equals negative 3. And this is equation 1, 2, and 3. So now we need to think about which variable do we want to get rid of. You can get rid of x, y, or z, it does not matter. Seeing that the last equation has a negative y here, I'm going to get rid of the y's first. So I'm going to use elimination with 1 and 3. So we have 4x plus 2y plus 3z equals 12. 6x minus y plus 4z equals negative 3. I realize here that I can multiply the second equation by 2. So my first equation doesn't change. So now I would have 12x minus 2y plus 8z equals negative 6. When I add these equations together, I'd have 16x, our y's cancel out, plus 11z equals 6. And this will be equation 4. Now, because I used 1 and 3, I either need to use 1 and 2 or 2 and 3. I'm going to use elimination with 2 and 3. So 2 is 2x minus 3y plus 5z equals negative 7. And 3 is 6x minus y plus 4z equals negative 3. Once again, I see I'm going to have to get rid of the y's. We have to get rid of the same variable each time. I'm going to multiply the second equation by negative 3. I rewrite my first equation. I multiply here, so negative 18x plus 3y minus 12z equals 9. When I add these equations, I have negative 16x minus 7z equals 2. And this will be equation 5. So now we need to either use substitution or elimination with 4 and 5. So in this case, I already see that our x's have the same coefficients, just a different sign. So I'm going to use elimination with 4 and 5. I add these equations together. 4z equals 8. So z equals 2. Once again, once I have z, I can plug it back in into either 4 or 5. I'm going to plug it into 4. (16x plus 11 times 2 equals 6). So now I have x. So now I can plug x and z into either 1, 2, or 3. In this case, I'm going to plug it into 1. It does not matter. So now I'm going to say 4 times negative 1 plus 2y plus 3 times 2 equals 12. Negative 4 plus 2y plus 6 equals 12. When I combine my like terms, 2y plus 2 equals 12, 2y equals 10, y equals 5. So once again, I have my order triplet of negative 1, comma 5, comma 2. That's my x, my y, and my z. All right. Our last example here, I'm not going to tell you which way you need to do it. You get to choose. Our first equation is x plus y plus z equals 1. Our second equation is 6x plus 9y minus 12z equals 14. And our third equation is 12x plus 18y minus 24z equals negative 11. Because equation 1 has coefficients of 1 in each of them, I'm going to use 1 and think that I'm going to use elimination here. You could use substitution, it does not matter. Now we need to think about which variable we want to get rid of. I'm going to get rid of x in this case. So I'm going to do elimination with 1 and 2. X plus y plus z equals 1. 6x plus 9y minus 12z equals 14. All right, so I'm going to multiply the top equation, getting rid of x, by negative 6. So I'll have negative 6x minus 6y minus 6z equals negative 6. I don't need to do anything to the second equation. When I add these equations, I get 3y minus 18z equals 8. And that will be equation 4. So because I've already used 1 and 2, I either need to use 1 and 3 or 2 and 3. Because I see equation 1 here, I'm going to do elimination with 1 and 3. So 1 is x plus y plus z equals 1. And 3 is 12x plus 18y minus 24z equals negative 11. I'm going to multiply the first equation to get rid of x by negative 12. My second equation, I don't need to do anything to. When I add these equations together, the x's cancel out. We'd have 6y minus 36z equals negative 23. This is equation 5. So now when I have both 4 and 5, okay, we now need to go through and say, we need to solve for one of them. So we're going to do elimination with 4 and 5. So 4 is 3y minus 18z equals 8, and 5 is 6y minus 36z equals negative 23. I'm going to get rid of the y's, so I'm going to multiply the first equation by negative 2. The second equation is fine. And now we should notice something right away. What's going to happen to both the y's and the z's? They're going to cancel out, and that's going to leave us with negative 39. 0 cannot equal negative 39, so there is no solution. As soon as we get no solution for any of these problems, we can stop right there. That's the end of this lesson. I will post the homework on Teams. If you have any questions, please reach out. Have a great day. Bye.